Hi, this is Discrete Math, section 8.4, mixed recursion. So we've done common difference before and we've done common ratio. Now we're going to mix them together. But before we do that, you may or may not have a quiz next time, but this is a review for the quiz. So start and try these problems, and then I'll show you the solutions and walk you through them. Probably not too much, but give you an idea of how to do these. Okay, so pause right now and try these problems and we'll check how you're doing. Okay, with this, we have a couple situations. The dots go by 1, then 3, then 6, then 10, and 15, and so on. This is much like the handshake problem, I believe. And so if you look at these and the common differences go up by 1, so it's second row difference. And I apologize for this other writing. I don't know what that is offhand. And then what you do then is you go to your calculator and then you find the formula that works for it. And so you do a linear regression. So then you go ahead and find the next 3 terms, which hopefully you did. And the next 3 terms, if you write them out here. And if you find the 50th term, you just can plug in, since this is closed form, you can just plug in 50. And so it's 0.5, and then I got 50 squared plus 0.5 times 50. And I cranked this out and I got 1275. Okay, so the closed formula, you can go ahead straight to the 50th locker and figure out what's in there. If you were doing, however, a recursive formula, you'd have to find out what's in the 49th locker before you find out what's in the 50th, so on. Okay, then if I look at this next one, common difference is all the same, so you could say it's a linear generator, but we also said that this is arithmetic. So if this is arithmetic, common difference, I can find this, use this formula to find any term, and there it is. Then we have a sum formula here, and with this, I have a difference of 6, 6, and 6, so this one's arithmetic too. So I take the arithmetic sum formula. I do not know the last term. If I don't know the last term, I use this one as compared to this one, right? So I don't know the last term. I go ahead and plug all this stuff in, and I am going to get whatever value you get there. Okay, you figure that out. And then number 5, this one's geometric, and so you use the particular term sequence and plug it in, and there you are. This one's a sum, geometric sum, because I'm multiplying by 2. So my ratio is 2. And I can find out what's going on there. That's the same as what we have there. And then number 7, what are the first 4 terms of the sequence generated by this? And so what we have is a common difference. This right here is my common difference. It's arithmetic with d equal to 4. And then this one here, what are the first 4 terms of the sequence generated by this? Well, I'm multiplying by 4. So if I'm multiplying by 4 each time, that's going to be my ratio. So this is geometric. Hopefully you're able to get those. If not, you better get in and get some help. Okay, then if we move on to 8.4, this is mixed recursion. Mixed recursion is using both forms, multiplication and addition. So if I look at my recursive formula here, here's a product and here's a sum. So it's putting both of those into my recursive formula. So when writing these out, I get 3. Then if I take the 3 and plug it in here, so it's 2 times 3, which is 6 plus 4, which is my 10. Then I do the 10, plug it in, and I get 20 plus 4, which is 24. So I'm just basing it on the previous term. 24 is 48 plus 4 is 52. And then 52 is 104, so I get 108. So there's my pattern, and this could go on forever if I wanted to. Now it's asked us to find the differences. So here's 7, this is 14, and if I do this right, I bet this is 28. We want to guess what this difference is without subtracting? 56. I bet the next difference is 112. What do I notice about all these? Well, here I took the difference. Now, if I look at going from one term to the other, come on, what did you find out? Well, I believe that we're going to be multiplying by 2 each time. So what happens is that we do have a difference, and then we also have a product here. which turns out to be 2 in this case. Oh, that looks interesting. Maybe that's the same thing. I'm not sure. But this is called mixed recursion. Mixed because I have both multiplication and addition at the same time. And this is the pattern that you'll see. You'll get differences, and then once you look at the difference, then you're going to be multiplying by some factor to get from one term to the next. Okay? So let's look at another example and see what happens here. What if I take the differences? These are off a little bit, but if I take these house prices and I look at the differences, so this one would be 2,000. If I do between these two, I get 2,200. And if I look between these two, I get 2,220. Okay? Now, do you see a pattern here? Would you guess what this number might be? 2,222? I don't know. Let's see what happens. This can't possibly be right. Let's double check our arithmetic here. That looks like 2,200. Yep. And then this is 24. I need a 4 here. 2420. So this one doesn't make sense. Okay, so maybe we're not dealing with that quite as of yet. So what we want to look at is this mixed recursion, since we're in the mixed recursion section. I don't go up by 200 exactly every time. Okay, so this does not have row differences as we've seen before. So what we look for now instead is, once we take the first row differences, can we find a ratio to get from one to the other? So we can find a ratio by going from taking any number divided by its previous number. So I'm going to take 2,200 divided by 2,000, and I'm going to get 1.1. And if I do the same for the other ones, let's see what we get. So I go 2,420 divided by 2,200. Oh, looks like we got a winner. Looks like we have a ratio of 1.1. So if I want to go from 2,420 and I want to go times 1.1, 2662. And maybe we could have guessed that one down here, but this one would be 2662. So this common difference is 1.1, and then this common difference, ratio, this ratio would be 1.1. So we are multiplying now. So you got to be careful in how you're doing that. This is a mixed recursion. Okay? Now before, what we found out was that the A value, so once I got down to this point down here, I was multiplying by 2 in our row differences. And that 2 might correspond with that 2 right there. I'm not sure, but let's go down here and see if this works. So in other words, let's see if A is equal to 1.1. Sorry, this should be T sub n. T sub n is equal to 1.1 times T sub n minus 1 plus some value of B. Well, if I want to find this B, so what we're trying to do is we're trying to find A and B, really. And so I'm guessing that 1.1, which is this ratio that you have here, is going to be this A, just from a limited experience, but I'm probably heading in the right direction. So what happens is that this A is 1.1, and we put it in here. How am I going to find B? Well, I have a whole table of values. I can take any term, for instance 82,000, and set it equal to 1.1 times the previous term, which would be 80,000, and then plus B. That looks like I can find B. Pause that and find. So I get B equals to negative 6,000. So I just take 1.1 times that and subtract. Okay? So let's see if this works. We're just speculating right now. So if we take this formula and I plug it in, so if I take 80,000, take 80,000 and plug it in here, well, sure enough, I should get this. So let's take a different value. Let's try to let this be 8420 or 200. Plug it in and see what you get. So if we plug this into our calculator here, it looks like we have credible evidence that suggests that this does work. Look at that. I take 84,200 and multiply by 1.1, subtract 6,000, boom. That would be my next term. Oh, this does look like this works. So if we let A equal this ratio that we have here, and then go ahead and plug in two numbers and solve for B, we should be able to get a mixed recursion formula for our mixed recursion. Okay? So there it is right there. Okay, annuity. Boy, we've done a few of these over and over again. So here's a situation that we have $1,000 on his 6th birthday to start his fund. Put $50 away for each month. So when he's 20, how much will he have? He's going to have to do national service. So we'll see what happens there. So what happens now is that we start with 1,000. Okay, so that's your A0. That's your first term, which is in this case 0. And then he puts away $50 each month from his 6th birthday to his 20th birthday. That's 14 years. Okay, so 14 times 12 will give me the amount of months that we have there, 168. The interest rate, since he's doing this monthly, will be 0.04 divided by 12. We can figure out what that number is, but I like to just leave it like that. Okay, so when we do our annuity, we go to our calculator and we can plug a lot of these things in. But let's write out our formula first. So if I do recursion, any term is going to be equal to the previous term, and I'm going to be multiplying by 1 plus 0.04 divided by 12. And then what else am I doing? Well, I'm going to be adding in $50 every month. Okay? So with this, oh, this looks like, is this mixed recursion? Look, we have multiplication and we have addition. I got to separate this out. And we have addition. So this is mixed recursion. So let's look at our values. Well, it's because we're multiplying and adding. So we can go to our calculator. We've done this a few times, so you should be quite good at this now. So we go to the correct mode. Should be sequence mode, and then we go y equals. I already have one in here, so I can just change this 0.06 to 0.04. Divided by 12, I get from second 7, and I just get from this variable button once you're in sequence mode. And then I'm going to be adding in $50 every month. And then my initial, look at, I started at times 0. Make sure you do that. And then this one here, grandmother gave him $1,000 to put in. And so for 14 years, he's going to be putting this money away. Now, what we say is the very last payment we're not going to make. So when we calculate this out, we can go to the home screen and we can say, oh, this is U of 168. Oh, missed my 1. And so if we put this in, we get that value. However, that includes one last payment of $50. Well, he's already going to college, so he doesn't want to put any more in. So he needs that money, so he's not going to put that in there. So this has included that extra $50 payment on that end of that 168th month term. We don't want that. So we're going to take this and subtract out $50. So that's one way to get it. So it's 12934 and some change, right? Now, going back to the calculator, the other way to do it is to say, oh, what if I do the, not 168, but I do 167th term. What has to happen, though, is that that money is going to carry through the very last month of the term and earn your interest. So if you multiply this times 1. I should do this. Since I didn't calculate out what the interest rate is, I got to write it like this. This is the pain about it. 0.04 divided by 12. What I'm saying is that that's the pain of leaving this like this. and I get exactly the same value. So to calculate these annuity values at the end of their term, you either go to the end and then subtract off that last payment, because on the last day of your annuity, you don't want to put $50 more in. Or you can take the 168th end of it, and then it carries through that last month to earn one more interest shot, and then both of those values would be the same. Okay, this is mixed recursion, has both multiplication and addition. And so we'll try to do some more stuff with this in the next section. All right, thank you very much. I hope you enjoyed this.